Hi, this is part 2 in decision tree algorithm, which is explaining how to select the best attribute for taking the decision in selecting the values into particular class. So here we are having two different attribute selection measures. Those are information gain and Gini index. Here, the information gain is used to measure the given attribute how better, which is separating the given training samples to classify into different classes based upon the target label. The information gain is refers to the decline, that means changes in the entropy after the data set is splitted. That splitting is called entropy reduction, which is used to calculate how much informative or information gained from the particular attribute to get better solution. Splitting the node is based upon the information gain value, and based upon the information gain the decision tree is starting to build. The decision tree algorithm is always attempts to maximize the information gain. Whichever attribute is having the more information gain, which is going to be splitted first. So that is the better attribute which is contributing more information to our solution. Uh, Calculating the gain by finding the difference between entropy of that particular attribute before splitting and entropy of that same attribute after the splitting. So formula is here the information gain equal to entropy of that given entire data set minus weighted average multiplied with entropy of each and every attribute. So this is the information gain, and here which is represented in the notation of entropy of S for the attribute A minus that information which is gained for that particular attribute. The entropy is the one of the term in decision tree which is used to measure the impurity of given attribute of random training samples. The entropy is specifying the degree of randomness in data samples, which is having the values to use for splitting the training samples based upon the information gain value. Whichever node or attribute is having highest entropy, that means more information gain, which is going to be selected as best attribute. Given collection of samples which is containing positive and negative samples for some of the target concept. The entropy of given collection of training samples is relative to the Boolean classification function, because which is mostly used for binary classification. So we are going to use Boolean classification like 0 or 1, yes or no, true or false. So here we are taking the S is representing the total number of training samples, P is representing the positive number of samples given in the data set, Q is negative number of samples, number of negative samples given in the data set. So the entropy of total data set is calculated by minus total number of positive samples divided by total number of positive samples plus total number of negative samples multiplied with log base 2 total number of positive samples divided by total number of positive and negative samples minus negative number of negative samples divided by number of positive samples plus number of negative samples multiplied with log base 2 number of negative samples divided by number of positive samples plus number of negative samples. Simply we can say minus p divided by p plus q multiplied with log base 2 p by p plus q minus q by p plus q log base 2 q by p plus q. So this is the equation to calculate the entropy for given attribute. So the entropy can be represented in the pictorial representation. Here, whenever the data is highly pure, 0 is representing highly pure, 1 is representing highly impure, highly impure. So in both cases, the randomness, that means entropy. So this is the entropy, right? Y-axis is entropy, x-axis is random, that purity. So if data is highly purity, that means all the samples are belonging to the zeroth class. Okay, if all the samples belonging to the same class, highly pure, and here one means all the samples belonging to the negative class, highly impure. If it is the case, then our entropy will be zero. Our entropy will be zero, right? Otherwise, if our data set is balanced, if our data set is balanced, 50% of samples belonging to one class, 50% of samples belonging to another class, that means 50% is impure and 50% is pure. So in that case, our entropy is 1. Our entropy is 1. So here we should consider the purity and impurity of the given data set. In this example, I am using the ID3 algorithm, which is one of the decision tree algorithm, iterative decoder measure, which is using the information gain measure to select best attribute from the set of attributes, which is giving the highest information gain while the tree is growing. So you see, for example, this is the given data set. From the given data set, we are taking the size is the size is the attribute. So from this, we are calculating the entropy. So based on the entropy, this attribute is selected. Then subtree, that samples is classified into two classes. So this is the simple pictorial representation. We will see elaborately in the forthcoming slides. So this algorithm considers the weather report 14 samples, which is default samples, standard samples considered for the decision tree algorithm. So already we have discussed the formula for calculating entropy minus total number of positive samples divided by total number of samples in the given data set multiply log base 2 total number of positive samples divided by total number of samples in the given data set, number of negative samples divided by total number of samples in the given data set, log base 2 number of negative samples divided by total number of samples. So here we are having 5 negative samples and the remaining 9 positive samples. So based on that, we are going to calculate entropy. Mostly entropy range will be between 0 to 1. The leaf nodes which is having the greater entropy is considered for further splitting. So here entropy of given data set S, which is having the 14 samples. In that 14 samples, 9 samples are positive, 5 samples are negative, then which is P divided by Q, P plus Q, then P divided by P plus Q, Likewise, it is q divided by p plus q and q divided by p plus q. So when you are substituting the values, 9 positive samples, 14 total number of samples, 5 negative samples divided by 14 total number of samples, you will get the entropy is 0.94. This represent 94 percentage of impure 94 percentage of impure data, that is non-homogeneous data. Another one example, if my data set is having 50 percentage of samples to positive class, 50 percentage of samples to negative class, after the splitting, then entropy value is 1 because our randomness is 0.5, our randomness is 0.5. So entropy is calculated for 80%, sorry, 80 samples positive class, 80 samples to negative class. So when you're substituting the values, you will get entropy is 1.0. At the same thing, if all the samples are belonging to same class, positive class or negative class, all the samples, 8 samples belongs to positive class, 0 number of samples to negative class. In this case, we will get the entropy as 0. And also another one case, if all the samples are negative, that means samples 8 samples are negative, 0 samples are positive. In this case, so in this case also we will get entropy is 0. Finally, we have to calculate average information gain for each and every attribute. So information of the given attribute is this pi means positive samples in the ith value of attribute. That means ith value means here outlook is having three different values. One is sunny, and another one is rainy, and the third one is overcast. So number of positive samples in the value of sunny divided by total number of samples belonging to the value of sunny, right? Like that we have to calculate the entropy of outlook for all the attribute values. Then finally we can calculate the average information to the given attribute. So this is the procedure to calculate the entropy for each and every attribute in decision tree. So thanks for watching.